Hello. This video will demonstrate how to find the limits of a rational function as x approaches infinity or negative infinity. And so when we're trying to find horizontal asymptotes, that's what we're really trying to find. What is the limit of the function as x approaches infinity or negative infinity? Okay, and as you can see here, there are three cases. So we'll be looking at three examples, one example for each case. In our first example, as you can see in this rational function, the degree of the numerator is 2 and the degree of the denominator is 3. So obviously the degree is larger in the denominator. As you can see, if I take this point and x gets big, the function approaches y equals 0. The behavior of the function approaches y equals 0. Okay? So, and same thing if I move right to negative infinity. Now, you're seeing something interesting here. In this particular case, it looks like the graph actually does cross y equals 0, right? So horizontal asymptotes are less strict than vertical asymptotes. All right? You can actually cross a horizontal asymptote. You can never, ever cross a vertical asymptote. And as we can see, we still have our vertical asymptote here, which you can figure out is the cube root of negative 4. Okay? Because the denominator cannot be 0. Okay? So that is our first case. The limit. Alright, so what we're saying is that the limit, and what was that function again? X squared plus 4x minus 4 divide by x cubed plus 4 as x approaches positive or negative infinity is 0. Okay, when the degree is larger. All right, and again, as I'm saying, it is possible to cross the horizontal asymptote. Let's look at case 2. Case 2 says, well, what happens when the degree of the numerator is the same as the degree of the denominator? Let's see what happens. Okay, so again, we have a rational function, and we can see here that our degrees are the same, and we have a horizontal asymptote. Notice we still have some vertical asymptotes as well, because the denominator can't be 0. But the horizontal asymptote, as x goes to infinity, what does the function do? Where does y go? All right, and what I can do, sort of squeeze that in to make it a little more visible, right? As x gets larger and larger and larger, it looks like k reaches some, the y value reaches some limit. All right, same thing here. If I'm going negative, it reaches some limit. And if I'm taking a guess here, between 1 and 2, it's 1.5. And what we can do is just look at the leading coefficients, 3 and 2. 3 divided by 2 is 1.5. So when the degrees are the same, to find the limit of the function as we approach infinity, as x approaches infinity, we simply look at the quotient of the leading coefficients. Okay, so again, we're looking at the limit of that function that we just saw on the graph, and very simply, as x approaches infinity or negative infinity, the limit of this function is 3 over 2. Y approaches 3 over 2 as x approaches infinity. Okay, now our last example. Okay, well, what happens if our last case is where the degree of the numerator is greater? All right, what we basically need to do is find what we call the slant asymptote. All right. We need to use long division sometimes if, again, the denominator is a linear expression, such as x plus 2, 2x minus 1, anything where the degree of the denominator is 1, we can use synthetic division. If the degree of the denominator is larger than 1, then you have to use long division. So let's look at an example. Remember, what we're trying to find is the limit of the function as we approach infinity. Basically, what we're going to be doing is looking at the limit of the slant asymptote. So it's important that you're able to find the slant asymptote. All right, so let's look at an example. Okay, so in this rational function we can see the degree in the numerator is 3, the degree in the denominator is 2. Again, I'm still going to have some vertical asymptotes. All right, you can, if you factor this, you'll have x minus 2 times x minus 1. Therefore, your vertical asymptotes will be x equals 1 and x equals 2. So don't forget about the vertical asymptotes. But it looks like instead of a horizontal asymptote, I have this slant asymptote. Now again, if you have the graph, it's pretty easy to see. As x approaches infinity, as x just keeps getting larger, y keeps getting larger. All right? So I can see, right, as x gets large, so does the function as we approach, as x approaches positive infinity. Similarly, as x approaches negative infinity, y approaches also negative infinity in this case. All right. Again, you may be asked to find the slant asymptote as well as the limit. So let's review how to do that. So here is our function, and because the denominator has a degree of 2, we cannot use synthetic division, and so we must remember how to do our long division. No problem. Be careful here, as you just helpful. If this is cube, right, I don't really have a square, so leave a space. All right, and that kind of helps there. All right, so you ask yourself, how many times does x squared go into x cubed? Or another way to think about that, what value or what times x squared gives me x cubed? Well, that's x. All right, and then we're going to distribute, right? So that's x cubed minus 3x squared plus 2x. All right, and again, what I do, I know you guys do something, you change the sign. I'm going to subtract, right? That cancels. 0 minus a negative, it's going to give me that. And 2x minus 2x, that's 0. No problem. And I'm going to just drop that. Okay? X squared goes into 3x squared 3 times. Now at this point, we're done, right? This actually, all right, our slant asymptote is, right, y equals x plus 3. All right. So when you are trying to figure out the limit, all right, don't forget what we're trying to do. We're trying to find the limit of this function as x approaches infinity. That really is the limit of my slant asymptote as x approaches infinity. And I hope this makes sense to you. As x gets really, really, really large, well, the value of the function also gets really, really large, so that's infinity. All right. If we are approaching negative infinity, right, this says as x gets really, really small on the negative side, excuse me, really, really large on the negative side, right, negative 10 to the 99th, right, and even bigger, right? The value of the function is also going to be a very, very large negative number. right? And that can be justified by looking at our graph. Okay? And what I did, I actually graphed the slant asymptote. This actually is, right? What just happened? No, 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 no. I don't want to change that. Anyway, yeah, there we go. Y equals x plus 3. It fits snugly within the larger graph x cubed plus 2x minus 7 over x squared minus 3x plus 2. Okay? Again, what we're trying to find, you have to read the directions. If it's saying find the slant asymptote, long division in this case, or synthetic division if you can. If you're asked to find the limit of this function as x approaches infinity, as we said, simply find the limit of the slant asymptote as x approaches infinity or negative infinity. Okay? Well, I hope that helps. Thanks for watching.